Hello and welcome to the Royal Academy of Engineering Education and Skills Policy Seminar Series. I'm Rhys Morgan, Director of Education at the Academy, and I'm your host for today's session. Sorry, there's a fly buzzing around. This doesn't happen at the BBC. I'd like to remind you that today's presentation and all our webinars are being recorded, and you can find them on the Academy's website under the Education section. If you're new to the series and you haven't seen our earlier presentations, I would recommend you go and see them. They are excellent and very thought-provoking. Today, we've been focusing on the younger age end of the education skills spectrum, but today we're going to leap forward to think about the workforce skills we'll be needing for emerging and future technologies. In the spring 2020 budget, the Chancellor Rishi Sunak committed significant extra public spending to R&D, £22 billion per year. And if there's any money left over after all the coronavirus bailouts, then focus will once again return to spending that money to rebuild the economy through innovation. The UK has always been a strong performer in R&D, but less so on the exploitation of that research to drive economic growth. And one of the reasons for that has arguably been the lack of skills in the workforce ready to take advantage of these new technologies. So with all the funding going into R&D, how will we ensure that our future workforce is ready, has the right skills in the right place at the right time? To discuss that question, I'm delighted to introduce Paul Shakspeare from the High Value Manufacturing Catapult. Paul is a long-standing contributor to skills in the UK. And that doesn't just mean you're old, Paul. He's worked in the defence sector on technology-based training systems. He's established training businesses in the UK, Asia, and Australia for the transport sector. He's provided training and skills consultancy for advanced manufacturing sector organisations such as the National Composite Centre and the High Value Manufacturing Catapult. He is a fellow of the Institute of Mechanical Engineers and the Institute of Materials, Minerals and Mining. The work Paul will be presenting has been developed from the Gatsby Charitable Foundation funded international study on the contribution of centres of innovation towards workforce development. And he was co-author of the report that was published in January 2020, Manufacturing the Future Workforce. He is now working with a number of organisations, including the Academy, to implement the report's recommendations. Just a quick reminder that we'll be doing a Q&A at the end of Paul's session, so do have your questions ready and put them in the chat box at the bottom of your screens. Okay, without further ado, I will hand over to Paul to present to us Manufacturing the Future Workforce. Thank you.
Good morning, Rhys. And thank you for that introduction and the opportunity to talk about this vital issue for our manufacturing sector, which, as we know, is critical for the UK's economic and social well-being. My presentation will describe the need that you talked about and an opportunity for our sector. It's a bit of a travel diary. It only contains a very small amount of maths, which for me is a criteria for any lecture, and sets out a collective plan before ending up with a call for joined up thinking and action. I hope you will find the scope interesting and look forward to questions later. As the High Value Manufacturing Catapult, our remit is technology innovation for manufacturing. We are a centre of innovation, delivering technical solutions and creating, as a consequence, new knowledge. However, we've long since realised that innovative technology of itself is insufficient and that it would better create better value if there's a workforce ready and able to exploit it, as Rhys introduced. So I'm going to cover background of why and how we felt that we might contribute, details and findings of our international study into innovation and workforce development, and our emerging plans. You will also hear about the concept of the skills value chain. So as a starting point, I'd like to explain HVM Catapult's current role. Next slide, please, Sophie. So, the High Value Manufacturing Catapult was established in 2011 by bringing together 7 existing technology and innovation centres from across the UK to work together. This enabled it to become rapidly established and gave an immediate scale that attracted industry collaboration. We're intent on seeing the UK secure its existing high-value manufacturing base, rebuild UK supply chains, promote reshoring, and grow new capability. The HVM Catapult's mission is unashamedly about creating industrial success with the accompanying high-value jobs in the UK. A couple of figures from our last published report. In the 2018-19 year, we did about 4,500 innovation support projects, and more than half of those were with SMEs. We have nearly 3,000 staff working in an asset base of £750 million. So this is a significant operation, and indeed is amongst the world's biggest in manufacturing. So what exactly do we do with all of that capability? Next slide, please. So the scope of HVM Catapult is diverse, both in terms of the sectors that it engages with and the technology capabilities that it provides to them. We cover about 27 key technologies, most of which are supported by several centres that have each evolved their capabilities over time, responding to and helping to inform market and technology change. Many of these technologies are now being applied to the national imperatives of net zero, mobility and sustainability, etc. Now, over several years, we've been doing a lot of thinking about people in manufacturing, particularly about the skills that our industrial workforce will need if we are to achieve the future for the UK that we would all, as individuals, aspire to. One with opportunity, prosperity and fulfilment for those people, as well as success for their industrial employers. So we take both an industrial and an individual approach. And during that time, we've been looking at the workforce development role of HVM Catapult as a centre of innovation. And because we are engineers for the most part, we've been looking for a system definition so that we might propose updates to that system to meet changing national requirements. I have to say that unfortunately, we've yet to find any wiring diagrams. Next slide, please. So we learnt many other things as we talked to people. And as ever, one of the key ones was not to assume that common sense is quite so common. The three-legged stool, as we, and it turns out others we found on our journey, christened it, of technology, workforce and supply chain, reminds us that our impact and contribution will be less if we fail to leverage the significant investment in technology resources for all three that we already have. We refer to workforce as a description of the individuals in the organisations that they work with. And we do this to help avoid the confusion of the many and varied interpretations of the word skills. The second bit of common sense was that if we have a present and forecast shortage of skills in manufacturing industry, then we probably have a skills pipeline that's sized to meet those needs at this current level and the content of throughput. This would be unlikely to meet future demands for any increased capacity or change content without development and investment. Hence, contributing to this national skills pipeline would be more effective than us simply taking on more trainees. And this led to a straightforward vision statement that industry should be able to access the right skills, right place, when they need them. And clearly, Reece has got that vision statement. This will in turn create success for the individuals who develop those skills to drive the change and who are work ready for future technology opportunities. So how do we sort of determine where the problem is now? So could I have the next slide, please? Bit busy this slide. However, many expert bodies have continued to research and continue to publish important commentary about failures and opportunities in this area. Indeed, the Academy is one of those producing useful information. They provide clear recommendations for action by industry, academia and government stakeholders. And as we know, some are taken up and many reappear in later reports. But one of the positive changes over the period of bringing our ideas together has been a growing agreement about the importance of continuing to educate and train the incumbent workforce. And this reflects the figure that something like 80% of the next decade's workforce is already in it. Well-educated, trained, and certainly work-ready apprentice and graduate recruits remain essential for employers. However, investment in their training programs provides a longer-term return than the immediate value that can be achieved by upskilling a current employee to meet tomorrow's needs. The points on this slide are looked at through the very specific lens of high-value manufacturing and reflect a situation and structure perhaps better suited to previous eras of manufacturing with their slower pace of change and less exposure to global pressures. Market pressure is often the justification for public action with an intervention that seeks to adjust or reset a market. Perhaps it would be better to describe the nature of the workforce problem as a systems failure, encouraging us to collectively cure the disease and not simply treat the symptoms on a repeated basis. My presentation is based on work that we completed before the effect of the pandemic on all of our lives. However, we think it has increased the relevance and urgency of many of our findings. So we now go on to look at how perhaps HVM Catapult could build on the reports we've talked about and take further action. Next slide, please. So firstly, what do we mean by a centre of innovation? And we think this is somewhere where knowledge of processes, tools and materials is developed on behalf of industry. A centre of innovation can be a permanent organisation, such as a Catapult, a research and technology organisation, university institution, or it could be a major project established to respond to strategic challenges. We were intent at the outset that there should be an open architecture for what we did to increase overall effect and avoid unnecessary duplication. It's worth highlighting that we already make a significant contribution to the industrial workforce by providing them able recruits. In some cases, this runs at well over 10% churn per year. And as HVM Catapult centres, we've already got a long record of delivering high quality apprenticeships and leading edge courses for masters, doctorates and industrial delegates. Looking systematically at all of these workforce development challenges, what else should we consider to leverage our overall impact, and what might our further roles be? So we discussed the hypothesis of this slide with our industrial, academic and government stakeholders, and we were fortunate to do this with Lord Sainsbury and the Gatsby Foundation, which resulted in their suggestion and support for an international study. Next slide, please. The scope of the study was to consider both the activities of centres of innovation and their education and training networks, so we would better understand how they were connected and worked together because of our systems type approach. As part of the open approach, we were joined by TWI and NPL, and we're pleased to have representatives from DFE and IFATE on some of the visits. This was not a benchmarking study. Our intent was to capture elements of good practice and pursue ideas about how they might contribute to the developments of where the current UK system is. We would then propose pilot projects that would trial and demonstrate how such good practice could be adopted. The full study and reports are available on our website and the references there. So I've now collected a few highlights to illustrate what we found and to remind us of when you could actually go to an airport and get on a plane. Next slide, please. The first one is from the Digital Manufacturing Institute, which is now called MXD, which is part of Manufacturing USA, which is a similar setup to our Catapult centres. They'd worked with the Manpower Recruitment Group, who needed to gain understanding of future job roles related to digital technologies. This graphic is quite interesting because it shows that our focus in manufacturing businesses need to grow well beyond the making part, which is in the top left-hand grey box. Engineering, the enterprise as a whole, and product life cycles are all connected by stronger digital threads, and these will become greater and more important elements in manufacturing, requiring new skill sets. The future job roles were defined by DMDII using a common taxonomy of capabilities that relate to each specific role and include relevant proficiency levels, and there are some 200 of these forming a hierarchy under the headings in the diagram. Now, this taxonomy is not dissimilar to others that have been developed, but it's specifically useful to us because it covers manufacturing. And by the way, we don't think we need digital in every role description. Next slide, please. America Makes is the additive manufacturing centre in Manufacturing USA. And a very significant proportion of their business is led by workforce development because that's needed to open the market up for wider manufacturing adoption of additive manufacturing equipment, systems and solutions. And so that means that there's commercial investment available in those courses, and they're often delivered by America Makes members themselves. Within this illustration is a very common sense concept that relates to the introduction of emerging technology. And it starts with awareness at the top of the flow, moves through generation of workplace competence and application skills, and then goes to embedding the subject in recognised and qualifications and programs to enable scaling up. No rocket science in that, but we thought that was a really useful way of expressing that process. Next, please. The LIFT Centre, which is a lightweighting centre developing mainly metallic technologies, was one of the first manufacturing USA centres to take the workforce agenda forwards under the Revitalising American Manufacturing Industries Act. It continues to be in the vanguard of activities with projects covering schools curriculum, sort of similar to T-levels, training of ex-military personnel, and works with many universities and colleges to extend the concept of work and learn. This particular programme involved LIFT members technologists working with selected academics drawn from universities and community colleges, and they worked together to develop future curriculum for their institutions such that their students would graduate with the skills appropriate to these technologies. And that saying there, bring upstream the conversation about education and workforce strategies about emerging technologies, underpins much of our thinking. Next slide, please. So going to Germany, this slide captures some key industrial digitization themes, which are many-faceted and not simply technical. Industry 4.0 is a very clear German brand with strong and shared marketing messages across all stakeholders. And I guess those messages are in that word cloud there. Discussions about the digitization needs of smaller companies centered on fundamental requirements. Start off with being good at manufacturing that you do, then being good at the change management to take you forwards, and all the time make sure that you're cyber secure. We quite enjoyed the tractor picture given to us by a man in Bonn because it illustrates how a now sophisticated, complex, expensive device reliant on rafts of electronics and communications for its efficient operation, and it's part of a larger and very connected food system. Yet, the maintenance technician still needs a van large enough to carry the same, if not bigger, hammer and spanners that have always been required, and the range of skills required by this technician has been extended and not just altered. And these are quite clear messages that we picked up in many places. Next slide, please. So this is the only maths bit, and it's only a little bit about addition and subtraction. The graph is typical for a number of professions and illustrates that the net change figures in the red dotted box are the sum of much larger gains and losses shown in the blue. And again, apologies for this not being rocket science. Looking at the time periods, this emphasises that many of those in the current workforce will require new skills if they are to remain productive, and new entrants will need to bring those future skills and then to keep agile by replacing them throughout their working lives. At the same time, a consequence of digitisation is the reduction of professional and technological boundaries as continuing change places additional demands on today's roles and will often require entirely new roles to be developed. And that echoes what we saw in the States. Jobs themselves will become more permeable with greater transferability of skills between future roles and duties in a growing, complex and changing mix of skills. So I think this issue about there being positives and negatives and needing to understand both is very important. Next slide, please. So we saw learning factories of various sorts in all of the countries that we visited. Indeed, some of them were actually linked globally to increase their scope for learning about supply chains. And we saw the name McKinsey over the door on quite a few. Where they're related to Industry 4.0, they provide a simulation of a complex industrial platform and use learning scenarios within that simulation to support the education for the future of manufacturing. So they're not training devices in most cases, they're used as education devices. The Baden-Württemberg Smart Factory initiative was really impressive. So 40 technical schools implementing a standardized approach which attracted state and local funding if they followed set criteria, such as set out in the blue box. This means that their learning equipment might be based on a brewing technology or a watchmaking technology, but it covered the same underlying principles of Industry 4.0 in all cases. The college that we visited had found that the complexity and range of subjects in the Industry 4.0 collection with its increased need to think about cultural change, was very demanding of teaching staff who needed the support of their institutions, their peer groups, as well as industrial partners for them to make a success of this activity. We also noticed that the colleges were operating perhaps in advance of the demonstrable needs of smaller companies because of the lead time to put this technology into place. Next slide, please. So as you would expect in Singapore, everything quite organized, and there are strong connections between all of the elements of industrial strategies, including the workforce in the sense of the three-legged stool. Skills Future Singapore is an organization that just does what it says, and it takes a modular approach to education and training, often using units from existing programs as standalone courses. And in many ways, we could see this as similar to our Open University and its related portals. It also sponsors the introduction of new technology modules into that program. This provision, however, is supported by funding schemes that prioritize the needs of those whose current skills may not fit industrial strategy, and for smaller companies seeking to update their capabilities. Interventions are planned before the change event and not after the jobs have been lost. This proactive approach is made more feasible and viable by the combinations of learners on courses, so adult learners attend the same modules as young full-time students. And lastly, in this highlight piece, next slide please. This actually was our first of the visits to the National Institute for Bioprocessing Research and Training, NIBRT, in Dublin. And this centre, which was really impressive, was built with inward investment money specifically to attract major pharmaceutical business to Ireland, which had previously had a very low skills base and no pipeline really. NIBRT's an industrial standard facility which replicates state-of-the-art technologies, processes and behaviours, note the behaviours, to provide an environment where work-ready skills can be developed. Many Irish HE students looking at related subjects attend this centre now, as well as a number of commercial delegates. Over the time of NIBRT's operation, some 10 billion euros have been invested in Ireland's pharma industry, and some of that must relate to the existence of the centre, and NIBRT itself has now developed an innovation capability as well as a training capability. However, we observe that as an independent training business, such a centre would need to generate additional income to support training and education activities. However, its contribution to overall economic value, as I think the 10 billion shows, would far exceed such a cost. Next slide, please. So again, details of all of the visits are available through our website. So what do we do with all this useful information? Well, our remit was to reflect on the good practice that we'd found and to work out whether and how we could adapt it to address the challenges of current UK systems. This slide captures the key issues that we felt would need to be addressed. It's clear that industrial digitisation increases pressure on education and training resources and requires investment, especially to develop and maintain the capability of teaching and training staff. And we think we saw quite a lot of evidence that they should be supported by this sort of concept of blueprinted learning content wherever possible. So working together rather than working individually. We also contrasted the fragmented nature of the UK education and training system with the common purpose that we observed during all of our visits. And that common purpose arose for different reasons in each location, some of them economic, some of them social, some of them because it was the right thing to do. But nevertheless, it had a similar effect of uniting rather than dividing what could become competing resources and efforts. So taking these reflections, our study arrived at a major conclusion, which was the need to address the overarching opportunity to create greater connectivity and cooperation across the UK's workforce development systems. And then we wanted to enable this with detailed recommendations. Next slide, please. So we came up with the concept of the skills value chain. And that was deliberately to help us to enable common purpose. And we started by identifying objectives that would help us to align future workforce skills with emerging technologies and to help us understand what roles centres of innovation should take. Value and availability of skills for industry and individuals is vital to anchor the benefits of innovation in the UK. We propose that we should use our position as centres of innovation and work with others to establish the demand for future skills, to develop the resources to deliver them, and to help diffuse delivery to the point of need efficiently. There's something in this about efficiency, which is really important. Animation, please, Sophie. Thank you. These activities that are now listed in the value chain activities take us from emerging technologies issues on the left through to workforce skills on the right. As my colleague Ian Colley, who I work with on this project, put it, going from when the technology is extraordinary to where it has become every day as you go from the left to the right. The roles of sense of innovation change and probably reduce as that transition occurs, but are vital to ensure that the pipeline of skills is in place for when and where they are required by industry. And looking across the whole value chain, the emphasis also changes from that of investment at the start to return as the economy benefits from the applied skills. Behind each of these activities, there are complex issues, and in the real world, there will be non-linear progress. We do, however, think that all of the steps are required, even though they may not necessarily be done in this order. In our detailed recommendations, we also propose a number of areas that would illustrate how this whole value chain could be taken forwards to implementation and to encourage the collaboration and delivery and integration with existing and already planned initiatives. So I'll come on to those next. Next slide, please. So our detailed recommendations were these. The first one, skills foresighting, is a natural development of our role in technology road mapping and our work with industrial strategy projects. And as you'll hear shortly, we've already taken steps to develop that. The second point is where the UK is now comparatively weak in the provision of higher technical skills. And they, as you probably know, have been a traditional upskilling route for those already in work. I think our comparative figures are something like 7% of our cohort in the UK is studying this area, where in the States it's nearly 30, Singapore I think is over 40. So a modular approach to development of content and delivery should be the most effective response to help us solve some of those needs. And they can respond to continuing and incremental skills changes. It must include the teaching of teachers for all new subjects. We think the learning factory concept will provide a platform to connect the technologies and expertise of centres of innovation with education and training institutions. And we're having very interesting conversations with the group of institutes of technology. And this could build on a common approach such as we saw in Germany. A colleague, Stuart Edwards, is now extending his previous study on learning factories and will produce a report in the autumn. The final detail takes into account that an individual has a central part to play in the development of their own skills that will provide them with future opportunities associated with emerging technologies. Recognition of modular learning and associated credentials and their accumulation into awards and qualifications will underwrite their transferability and value. And we think there's some important conversations to be had here with the professional institutions. Clearly, there's already a lot going on. So we're working with stakeholders to better understand how some of this can be connected and where further work is required. Next slide, please. So looking at the first of those recommendations and looking at foresighting. So foresighting picks up that phrase we learned in America about bringing forward the conversation about the workforce requirements associated with new technologies. And we've been working with the team from Ingenuity, MTC and NCC, led by Dr. John Lanham. The project aims were to develop processes and tools, as well as to produce gap analysis of recommendations for a number of emerging technology subjects that might then contribute to the scheduled I-FATE review of engineering and manufacturing standards due around about now. We built our processes on good practice elements from the USA, adopting the use of expert educators and common taxonomies. There was some interruption to our original plans due to the pandemic, which meant that we've completed trials somewhat not like we expected, and using the closely defined subject of composites and aerostructures and the much less well-defined digital manufacturing, and are working in parallel to incorporate previous work on additive manufacturing and electrification. The good news is the overall process is now well defined and sets out inputs, outputs, and the involvements of technologists, educators, and employers at each step, using common terminology and taxonomies. Next slide, please. So our objective is to generate evidence that describes and promotes timely action throughout the follow-on skills value chain activities, which then leads to the right skills, time and place mission. At each stage, specialists apply their expertise. Strategists might put in what are the workforce trends and drivers. Technologists will understand what new capabilities will impact on workforce requirements. Educators should be able to understand the knowledge and skills and behaviours needed by individuals, and employers how they would come together as roles and duties and qualifications in the future organisations. The purpose of all of them is to define a view of the future state of skills required to successfully respond to the technology strategies and investment at the right time. These future state findings can then be compared with the current state, which in the case of the pilot we've been doing was apprenticeship standards. It could be provision, it could be a company's in-house learning and development systems. And this can then prioritise and recommend actions to be taken forwards by employers and stakeholders. The use of common terminology and taxonomy is vital to avoid confusion and to maximise impact across sector boundaries. And also, I think, technology boundaries going forwards. Next slide, please. So as well as minding our terminology P's and Q's when it comes to the use of the words competence, capability, capacity and others, this approach builds on two sets of common data. One of capabilities to allow cross-sector organisational definition, and that uses the concepts we saw in the States. And this is a direct route to allowing us to capture changing duties that will then inform future competence needs. And we then take the common competence descriptors of knowledge, skills and behaviours, categorised under the headings of fundamentals, emerging, business and digitisation, which help us to facilitate cross-sector and cross-technology use. All of this enables comparison and prioritisation for the employers and the stakeholders, but it maintains the evidential link to the strategies that are driving the need for skills change. Very often we would comment that we look in the rear view mirror rather than through the windscreen when we look at our future needs. So it's really important to get as much future information as possible. And we're just about to report our findings and make proposals for the continuing work. Next slide, please. So again, foresighting is not rocket science, but it does require those various participants that I talked about to work together with common purpose. And that's really one aspect of the skills value chain at a detailed level. It would be fair to say the pandemic made the exercise a little more complex, but it did allow us to accelerate thinking about better engagement and more efficient online processes that allowed us to work with wider groups more efficiently. However, the analysis of future and current state gaps is time consuming and would become a limiting factor without automation. The good news is we know automation is available. We're now talking with stakeholders to help define an implementation stage of the concept when we wish to define and agree quality assurance processes and to develop the tool sets with partners that will increase the contribution of the specialist groups and automate the analysis and reporting. So we intend that we should build this into the processes around road mapping, and we need to understand exactly how that fits. Now, of course, foresighting is really only the first activity in the skills value chain. So we're also seeking to demonstrate how this informs the follow-on activities. And we can already see how the process outputs should contribute to the work of institutes of technology, higher technical qualifications and retraining schemes. So in conclusion, next slide, please. I'd like to leave you with a simple view of how workforce development activities connect and how they enable industrial change. And at its essence, this is the simplest way we think about the skills value chain. We've had some pretty strong feedback that this is quite a useful framework to place activities in the context of others and to understand their interdependencies. Now that's a really good outcome because, as we say in our report, we advocate its adoption not just to allow the UK to catch up with other nations, but as a potential source of real competitive advantage in what will undoubtedly be interesting times for our manufacturing and other sectors ahead. HVM Catapult is now working with Ingenuity, Make UK and the Academy to bring together a critical mass of organisations wishing to share this common purpose and to work with stakeholders in industry, academia and government to deliver this opportunity. As with all of our work so far, we expect this to remain an open partnership and we will welcome others who have roles to take in it. So, finally, having taken you on our journey of why centres of innovation have a key role to play in workforce development, some of our travels to find out how we might do that, and finally set out our plans, thank you for your time and attention, and I hope that you found some of the ideas challenging as well as interesting. And I'd like to end with thanks to the Gatsby Foundation for their continuing leadership, support and funding, which enabled us to do this work, and to the Academy, Rhys and his colleagues for arranging the seminar. Thank you, Rhys, over to you.
Thank you, Paul. That was really stimulating and very thought-provoking, and I hope our viewers found it so too. I'm really just interested in this this piece of work. It's so important to the Academy and what we're doing. And the thing that kind of I'm trying to get my head around is the role of higher education institutions, FE colleges, alongside centres of innovation. I just wanted to kind of test with you a kind of a worked example. And if we tried, let's take additive manufacturing. It's a subject close to my heart. I did my PhD in it in 1996, so that makes me nearly as old as you. And the thing about additive manufacturing is, of course, it's a digital manufacturing technology, but the whole purpose of it is to take human intervention out of the system. We want to avoid those human errors. And if you take a look at some of the high-value additive manufacturing processes, the powder-based laser, selective laser melting processes, actually, it seems that it's not that digital in terms of the skills needed by technicians and graduates. So, for example, technicians would need powder handling skills, so safe powder handling, sieving, blending, maybe alloying. And likewise, graduates would need powder metallurgy understanding and knowledge and things like that. These seem like, you know, going back 50 years. These are not modern, advanced kind of skills. So, and I guess that, you know, our engineering departments aren't teaching powder metallurgy in the way that we might need it at the moment, or if these technologies take off in greater numbers. So, is that right? Am I understanding that right? We need to just kind of rework what skills we need and then embed them back in the education system.
Yes. So if you recall, when I talked about the underlying structures in our foresighting process, I talked about competence structures which were based on manufacturing fundamentals, emerging technologies, business management, and digitization. And we over time developed those four headings to respond to the very issue that you raise, which is not everything's new, some of it's old and we've just forgotten about it. So for instance, in the work we've done with digitization, I think something like 40% of the competence sets fall under fundamentals, even though they arose from discussing the need of digitization. So what we're trying to do is take this modular approach, which brings forwards things we may already have. There's another debate about the capacity of our institutions to deliver material science, which is an entirely separate debate. But those things come forwards by looking at the entirety of a capability and the competences you need to conduct that capability. So you're entirely right. A lot of the stuff we need for the future is old, but some of the really tricky stuff is going to be new as well.
Right. And I'm just really interested in this, that you identify organizational capabilities, and which then leads to individual competencies. Can you just elaborate on this? Because I think this is a really interesting new thing for me, to think about the organizational capabilities first and then go on to the competencies.
So if we take the sequence, you know, we look at our major sectors, they've got clear strategies supported by roadmaps about where technologies and markets and so on are going to go. And they identify the challenges for our success in so doing in those marketplaces. Now, what we then are tempted to do is go straight from those industry level, sector level collections of information to what it means for an individual in the workforce. But of course, what it means for an individual in the workforce is heavily dependent on the sort of organization they work for. So if you work for a very large organization, you might well be trained as a digital architect, for instance. But if you work for a small SME, you might need some digital architecture competence. So it's quite important to look at the context of the individual in the whole industry. And that's where we use the concept of organizational capabilities, because they help us understand what sort of people will need the future skills. And of course, it also helps us understand in a parallel work what our supply chain should need to look like, of course. And you can't really separate those, because the future of your supply chains will be the determining factor in how many people you need with the skills in future. Back to the three-legged stool.
Yeah, absolutely. And you mentioned the kind of SMEs there, and I'm interested in this because, of course, 70 to 80% of the workforce of 2030 is already in the manufacturing sector. They're already in the workplace. So how do we incentivize SMEs to train their staff, and how do we incentivize individuals? It's a really interesting kind of situation we find ourselves in with the COVID-19 crisis. I've got, I promised myself I would read a whole stack of books while I was not off from work. And yeah, I've not managed to read any of them, despite some kind of intrinsic motivation on my part to do it. So how do we kind of incentivize, motivate people to kind of upskill for these new technologies?
I think it has to relate to the value accrued by the upskilling. And what we saw in the States was very often SMEs were their technology needs were not addressed through a sort of technology portal. They were addressed through a workforce development portal, because that allowed those small organizations to have an immediate effect on their current problems. So problem-based learning was meeting SME problem in a sort of structured and locally supported way. So we've got this segregation between, you go and develop a skill, but actually that skill in a small company needs to relate to a fairly short-term need. And I suggest that short-term has become even shorter term in the last few months. That releases both the fees necessary to buy that training, and that could be the apprentice levy, and of course the more important cost of the time of the individual to undertake that training. So both of those things need to come into play. And what we focused on through our modular and incremental approach is that we need to break things down into modules that meet an appropriate level of need, but that could also be assembled as a full qualification or whatever. So it's about having this dual purpose of things. And I think the Singaporean example is a really good one of that, is that they can encourage with state money, and I'm not suggesting for a minute that's what we need to do here, with state money, people to go on modular courses, because the cost of those courses has been mitigated by them being part of a larger educational institution. So I think incentivizing people has to come from creating value in their engagement with the skills system, but also responding to real and pressing problems of those smaller companies. We can't beat them over the head with taking up artificial intelligence or something if they're still struggling with getting their website up together.
Yeah, absolutely. Thank you. There are lots of questions coming in through the Q&A box, so I'll just go through them one by one. So Chris Eady asks, he says, by definition, emerging technologies exist in R&D facilities, not mainstream employer businesses. R&D has traditionally created spin-off businesses to transition technologies into production. Is it necessary to plan to accelerate the spin-out of the best talent from innovation centres to transition future skills into production? So can we plan that? And if so, how do centres of innovation continue to deliver their R&D objectives with the turnover of their best people into the spin-out businesses?
Hi, Chris. I think that the innovation type spin-outs tend to be from university-focused centres of innovation, where individuals can drive their ideas forwards. What we're talking about here is where those research ideas have moved into the valley of death, as we know it in technology readiness levels, the middle stages, where industry is reluctant to take individual risk on some of the technologies coming into their businesses. So I don't think we're talking in the main about spin-outs. That's certainly a route which exists and is difficult to plan for. Although we did see an example in Germany about where the local state had tried to close the loop on university students leaving university and going to small companies because they were leaving their workforce control. So they were trying to bring them back in by offering them market support and so on. So there are various ways and means of doing this. I think Chris's point is right, but we were focusing on the more structured evolution of technologies from the research stage through the catapult type organizations into industry. So I think we're working those mid TRL levels, not straight from the early TRL levels.
So a good follow-on question then from Muir MacDonald is how you were talking about TRL levels then, and we might talk about timelines. So from a foresight needs, what are we talking in terms of timescales range here? What TRL levels would we start to think about this skills mapping for these new technologies? Obviously, we're not going to do it for blue sky research, but when in the kind of innovation cycle or the R&D cycle would we start to think about these?
I think it's almost in the middle of the technology readiness level chain. When the technology has become set, but isn't yet developed for industry. And there's another issue here to do, and it's more really timeline based, Reece, I think, than TRL level based, because what we've looked at with the foresighting criteria is there is little point in looking at things that are too close in their need for us to impact before they hit us. That's almost a redundant activity. There's also little point in looking at the second horizon beyond which there's too much uncertainty. So for instance, if we were talking about probably nuclear technologies, they might lie between 2 and 10 years. If we're talking about some digital technologies, that might be between 2 and 12 months. So each time we look at a subject, it will have a different pair of horizons, the short term and the uncertainty one. And it's a bit of the Rumsfeld known unknowns, etc. going on. Yeah. Yeah. But we do think that our role as Centre of Innovation, and this is not just HVM Catapult, there's all those involved in the process, are pretty uniquely placed to look over the horizon far enough to make an impact that can make a difference. It's unlikely that employers, particularly smaller companies, would have the time, the inclination, or the individual understanding of what could happen with some of these things. Some might, and we should track them down, but we shouldn't force it on these people as a role. We should advise them, and they can make the decisions. If they don't like what they're being told, they can always ignore it. But actually, we're there to produce evidence which says, if we're going to have this technology through this strategy, the impact on workforce is this.
Okay, so the skills value chain diagram you showed had highlighted the role of centres of innovation, and you mentioned there about different actors in the R&D cycle. Where do researchers at higher education institutions, their teams, where do they engage with this value chain then?
We would see them very much in the foresighting stage. Now, depending on where their research is, but if they're moving closer to industry, then we would expect them to be contributing into the foresighting process. So we see them as, in the language we use, we see them as both technologists and educators in some circumstances.
Okay. Dave Delpy asks, he's looking at how other countries do things. Did you note any overall structural or organizational factors at a regional or national level that enable this common purpose, which may be missing from the UK, given that the UK seems to have a more disparate and competitive research, education and training landscape compared to maybe other countries?
It took us a while to realise what we were seeing, because we've been sort of sheep dipped in our own systems. But we realised in the end, I think it was when a very senior professor in a very senior university, ETH Zurich, sat us down and told us about the Swiss apprenticeship system, because he reckoned that gave him some of his better students. And so we realised then that if we'd have asked a professor in one of our own universities, we probably wouldn't have the same story, without being too pointed. And we began to look at this, and we realised that for different reasons, there was a common purpose across the workforce development piece, which didn't have competition between those entering apprenticeships and those going to university and so on. It was seen as a whole system. Now, there are caveats around that in terms of social change and pressures. But for instance, we saw in the States where the Workforce and Innovation Opportunities Act, underneath the Department of Labour, would pull together the activities of those involved in it from other departments to make sure it was consistent both at a federal and state level. In Singapore, we saw the same thing, and that I think was less formal, but everyone seemed to realise in Singapore, because they could walk to see each other, that if they worked together, everyone would benefit and, bluntly become better off. So there's a whole range of reasons. In Germany, it's the social charter, for instance, where the role of the chambers, which is very different to our chambers here, bring together social, economic, and individual needs on a local basis. So I think there are a number of different reasons, but overarching all of those is the fact that they work together for common purpose. And I would add a further comment, which is in each of the countries we visited, there was a Department of Labour whose job was broadly to look after the renewable human asset of the workforce. I don't think we have a comparable intent in the UK at the moment.
Yes, that's really interesting, because we have the Department of Work and Pensions, but it's quite a different kind of emphasis in there, isn't there? You mentioned apprenticeships and apprenticeship standards, and I wanted to kind of just come up on this, because in England, apprenticeship standards are overseen by the Institute for Apprenticeships and Technical Education. And would it be improper to say they're not exactly fleet of foot and in developing new standards? And of course, it's down to employers now to help develop these new standards. So with these emerging technologies, how do we make sure that we can be more agile in developing standards if they are then to be taught in apprenticeships or technical education?
I think our colleagues in IFATE are a lot fitter and fleeter than they have been at the start of the whole process. So we very much are wanting to work to help that process continue to become more agile. Indeed, I believe it will do. As part of the foresighting process, my colleague John Lanham has developed this concept of a fit factor, where we can produce a number which says how closely a current standard meets a future need. And what's quite interesting is that's determined by the language used in the standard. So in terms of how it fits, and that really is a reflection, an inverse reflection of its barrier to progress, the higher level standards are often a better fit because their language is written more loosely than some of the detailed lower level standards, which make the fit more difficult. So some of this is in how we use language. And as an example, when we visited BIBB in Germany, I think we were told that the office professional standard hadn't been reviewed or rewritten since the 80s. But the one thing I'm pretty sure about is office technology and practice has changed substantially since then. So it reflects how the standard was written in the first place. And I think that's one of the things which we know IFATE is looking at in terms of the use of shared language across standards. The Trailblazer groups are looking at that as part of the engineering and manufacturing panel reviews. And indeed, we're talking with the Trailblazer leads as to how we can feed in the outputs from our analysis into that common language. So, working with Ingenuity as well, this is quite interesting ground now, that some of the tools we can use, the artificial intelligence language analysis tools, allow us to really pull out where the commonalities lie. And it sort of echoes the comments I was making about the use of manufacturing fundamentals, emerging technologies, and so on as categories, because it helps us to highlight what is common and what is specific to future needs.
Great. We are coming up to the witching hour, I'm afraid. One last question from Jed. Paul, if you could do anything at all, what 3 things would you implement or change tomorrow?
Thanks, Jed. I would first of all remove the barriers across some of the education systems. So this depends what level of fantasy you're at here. But I really believe that we need to get to a situation such as we saw in Switzerland, where it is accepted that their system, you might start off as an apprentice, and they had a big billboard up when we were there, which had a picture of a shaving brush and an ostrich. And its tagline was, start off as a barber, complete as a biologist. And that's what I would really like to see. And to do that, we need to fundamentally change perhaps some of the core fundamental components of our general education system that don't remove opportunities as we go through. I think in this country, we see, your 3-year chance at education, whether it's an apprenticeship or a degree, whatever, is it. So my second point is that lifelong learning is critical. And I would want to find a means where individuals were motivated and incentivized to take that forwards themselves, because I'm not sure we're going to have the same structures of employment as we've had in the past. And I'm going to pass on the third one because those two things for me are vital. It's about having
they're
that
pretty big asks.
and,
Very good.
And this lifelong learning.
Yes, indeed. Paul, thank you once again for a really interesting talk, very thought-provoking, very stimulating, and quite challenging actually as well, and a great Q&A. That's it for us for this week. Next week, we will be hearing from Dr. Ruth Graham on, she's not from the High Value Manufacturing Catapult. No, she is a consultant, and she's been working with MIT to look at the global state of the art in engineering education. It's going to be really fascinating. I do hope you can join us, 11 a.m. That's it for now, and we will see you next week. Thank you.